Hello there, this is a geometry video. It is chapter 11, section 4, and today we will be discussing areas of regular polygons and composite figures. I do believe that this is, of all of the sections in this chapter, probably the most complex. I don't mean to say that to scare you, but it's not going to be, I just want you to be aware that it's not going to be as easy as finding the area of a circle or of a parallelogram like we've been doing in the past. But to begin, I want to first remind you of what it means to be a regular polygon. Whenever you see the word regular indicated when it comes to polygons, there's two things you have to remember. It means that all of the sides of the polygon are the same, and it means that all of the angles of the polygon are the same. Otherwise, it wouldn't be regular. Okay, so that's important to know as we continue. The other thing that I want to show you is kind of explain this diagram for you a little bit here. What you have is basically, in this case, it's a pentagon, but it could be any regular polygon, and this polygon is inscribed in the circle, okay? And we've done that on purpose because the center of the circle also happens to be the center of the polygon. And so that means that any segment that extends from the center to the circle is a radius, and would therefore be congruent. And so what you kind of get here is an isosceles triangle going on. And then what you have here in blue is the height of that isosceles triangle. But I want to be very clear that you can see from the diagram that this segment, the blue one, doesn't extend all the way to the circle. So clearly the blue segment is shorter than the radii, which are these segments here. Okay? And so we have a special name for that segment. And it's called an apothem. Now, I'm not a linguist, so I'm not exactly sure if I'm saying that correctly. It could be apothem, but I've always heard it said apothem. So I'm going to say apothem, and if I'm wrong, you guys can just deal with it, I guess. All right, so over here I've kind of described the elements of what's going on here. It's important that you know what the apothem is, because to find the area of a regular polygon, we have a formula that involves the apothem. So a radius is like, I already diagrammed here, but you can see here it's AP, segment AP from A to P. It goes from the center to the actual circle. The apothem, however, is PF. It doesn't go all the way to the circle, it's shorter. Angle APB, so here's angle APB, this angle right here, is a central angle of the regular pentagon ABCDE, so this angle right here. And furthermore, we can find its degree measure because if you wanted to, you could continue to draw the radii to all of the vertices of the polygon, and you would have as many triangles as you do vertices. So I can show you very quickly here. I'll erase it afterwards, I don't want to ruin my diagram. But you could do that, and you would have 1, 2, 3, 4, 5 of these triangles in there, and then each triangle, this would have to add up to 360 degrees because we know that in a circle we have 360 degrees. So each of these angles would have to be the same because it's a regular polygon. So you would take 360 divided by n is the number of sides. It also happens to be the number of triangles that you have, and so 360 divided by 5 in this case, each of these angles has 72 degrees. That would not be so if it wasn't for the fact that it's a regular polygon. So just good to know how to find that angle measure. We're going to be using that a lot. So here we have, just to make sure that you're understanding what we're looking for here, it says example 1, square FGHJ is inscribed in circle K, and that's the symbol for circle. It's just a round circle with a dot inside of it. So inscribed in circle K. Identify the center, a radius, an apothem, and a central angle of the polygon. All right, then find the measure of a central angle. Identify the center. So for the center, it's kind of funny because whenever you name a circle, you name it by the center. So it says center K, but we want the center point here. It is K. So part 1 done. We found the center. The next thing they want us to find is a radius. It says A radius because there are two that are pictured here. You can either put segment KG. You only have to list one, but I'm going to list them both. KG and KH. All right, so we have two radii in this case, so you can put either one. And then it says an apothem. Now remember that the apothem is basically the height of the isosceles triangle that's formed here, or the segment that goes from the center perpendicular to the side of the polygon. So it goes from the center perpendicular to the side of the polygon. So in this case it's KL. And then we have, what else do they want here? We have the radius and a central angle of the polygon. All right, a central angle, remember, we find that the only one that's labeled here is going to, the central angle is right here. So it's going to be GKH, angle GKH, or you can call it HKG if you wanted to go the other direction. But that's our angle. And then it wants us to then say, it says, find the measure of the central angle. And that's easy to do. The measurement of angle GKH is simple. We take 360, always start with 360, and divide by n, which is the number of sides in the polygon. There are 4 sides, it's a square. So 360 divided by 4 is 90 degrees. So the measurement of our central angle is 90 degrees. And that takes care of all of the items they asked us to find. So now you can try this example, and then we will go on to example 2. Kane created the stained glass window shown. The window, now of course the window in your textbook is a lot prettier than this one, but you get the point. The window is a regular octagon, so that tells me right away that n is 8. It's a regular octagon with a side length of 15 inches. So this side length here is 15 inches. And that's going to be my base. And an apothem of 18.1 inches. So that's actually the height. The apothem is the same as the height of this. You can see now that we've kind of removed the circle, but you can kind of still imagine that it's there. But the apothem is right here. It's basically the distance that goes from the center perpendicular to the side of the polygon. All right, so this guy's the apothem, and it's basically the height of my triangle, which is 18.1. And it says, what is the area covered by the window? Now in this case, because we don't have the formula yet, and we will in a few seconds, well, a few minutes, the only thing that we can really do is find the area of this triangle and then times it by 8, because there are 8 similar triangles in this window. So we're going to find the area of this triangle, which is why I used base and height here instead of apothem and side length. But we're going to find the area of this triangle. And the area is going to be 1/2 the base, which we said was 15, times the height, which was 18.1, and then divide that by 2. And we're also going to then take that and times it by 8. So we can kind of just go ahead and do that too here. We can then take this guy and multiply it by 8 because we want 8 of those triangles to get the total area of this window. So 8 divided by 2 is going to give us 4. So it's 4 times 15 times 18.1. 4 times 15 we know is 60. So now we're going to go 60 times 18.1, which is 1,086. So the area of this stained glass window is 1,086 square inches. And there you go. So now we're going to ask you to do a similar thing. With this guy here. But then we're going to introduce you to a different method of finding the area when it comes to a regular polygon, because we have a formula. So the area of a regular polygon is equal to 1/2, the A value here is apothem, 1/2 the apothem, which is kind of like the height, times n times s. All right, now what is n times s? Another way to say n times s is perimeter, because n is the number of sides and this is the side length. So in a regular polygon, the side lengths are all the same. So if you had 5, 5, 5, 5, 5, it would just be 5 times 5 because there are 5 sides and each side is 5. So that's what it means by n times s. So another way of saying it, and the way it's most commonly used, is area equals 1/2 AP. 1/2 apothem times perimeter. So you can see in my diagram that the red here is meant to indicate that you are adding up all the sides. So if you started here, you know you're going to go this way, add up those 2, go this way, add up those 3, and that's going to be your perimeter. The side length here in green is just the side of the polygon. The apothem, of course, is the distance that goes from the center to the opposite side, perpendicular, of course. And then, of course, your radii are these black segments here. Alrighty? So we're going to try using the formula this time to find the area instead of trying to find the area of each triangle and going all the way around. Timesing it by whatever value there. So here we go. Find the area of each regular polygon, round to the nearest tenth when necessary. Okay, so we're going to do that here with our first example. It says a regular hexagon. Because it's a regular hexagon, there are some things that I already know. One of which is that n equals 6. Over here we have a pentagon, so we know that n equals 5. I'm also going to put for you over here the formula. A equals 1/2 AP. Just to remind us. In this case, I don't have the apothem value here yet. I can get it, but I don't have it yet. Over here, we also don't have the apothem value. And so what I'm going to show you is how, and this is why I said earlier that it's going to be, that it's a little bit more complicated than what you've been doing in the past. Not only is the formula isn't really that complicated, the formula is easy peasy. It's trying to get the apothem that generally makes things difficult for us. So we're going to start by finding our angle measure. This is how you usually want to start. You want to take 360 and divide it by n. And in this case, n is 6. So 360 divided by 6 is going to be 30, or 60, sorry. I knew that. It's going to be 60. So that tells me that the angle from here to here is 60. But I only want to find the area, or sorry, the angle of one of those sides, because I'm going to try to figure out, I know this is a right triangle, so I kind of want to see if I can do any Pythagorean theorem stuff or anything like that to get this value. So if this entire central angle is 60, I'm then going to take that 60 and divide it by 2, and that tells me that this angle in here is 30 degrees. And since this angle here is 90, it means that this angle is 60. And now that tells me that I have a 30, 60, 90 on my hands. And a 30, 60, 90, we know we can use the S root 3 and 2S, if you remember that from before. So I already know the side length here. So I know my perimeter is going to be the number of sides, which is 6, times 3. So my perimeter is 18. I can plug the 18 into my formula. I need the apothem. So now to get the apothem, which is right here, I know that if this side length is 3 meters, it means that half of it is 1.5. All right? So if this piece right here is 1.5, I'm just going to kind of type that in there, 1.5, then it means that this guy is 3 because it's twice that. Remember, opposite 90, this is my 2S, opposite 90. Here's my S, and it means that the apothem is S root 3. In other words, the apothem is 1.5 root 3. Okay, so now we're going. Now that we have that, we have everything we need. We have our perimeter, we have our apothem. We just plug it into the formula. So let's do that. Area equals 1/2. The apothem is 1.5 root 3, and then the perimeter is 18. So now we have 1/2 is 0.5, times that by 1.5, times by root 3, and then times 18. So it turns out that our area, we're going to round to the nearest tenth, 23.4 because it says 23.38. So 23.4, and we are in meters here, meters squared. 23.4 meters squared. Now we're going to go to the regular pentagon and try to see if we can do the same thing. Now in this case, we're going to again start with our 360. Come on, pen. Let's wait for the pen here real quick like. We're going to take 360 and divide it by 5 this time, but it's not going to give us a nice 36 like that one did. We're going to end up with 72. So 360 divided by 5 is actually going to end up with 72 degrees. And we still want the right triangle because in this example we're going to actually use our trig to get our value. So if the entire angle is 72, we take that 72 and divide it by 2 and we get 36. So it means that this angle right here is 36. Alright, now I can use trigonometry to find the value of the adjacent side and the value of the opposite side because I have the hypotenuse. So to find the value of the adjacent side, I'm going to need cosine. So cosine of 36 degrees is equal to the adjacent side, which I don't know right now, so it's PS because that's the segment PS, divided by the hypotenuse, which I know is 10. So if I multiply both sides by 10, then PS is going to equal 10 cosine 36. Alright? I also need to know what RS is, which is the opposite side. So for that I want to use sine. So we know that sine of 36 is equal to opposite, which is RS, over hypotenuse, which is 10. And we do the same thing to get rid of the 10. So RS equals 10 sine 36. Alright? And I want to keep those exact values because you don't want to round until the very end. If you round too soon, then your answers get off and then it doesn't match the back and then you think you did it wrong. So we're gonna wait to round to the very end. Okay, I'm going to erase this so I can give myself some more space here. And so now we have everything that we need because RS is half of the side length. So I need to times RS by 2 because the side length will be twice that. So I'm going to get 2 times 10 is 20 sine 36. Alright? So now I can plug it into my formula because my perimeter, sorry, I'm not ready yet. That's the side length. The side length is 20 sine 36. But to get the perimeter, you have to take the side length and times it by 5. So 5 times 20 is now going to give us 100 sine 36. So we're going to have 100 sine 36 as our perimeter. That's the P part. The apothem is right here, PS, 10 cosine 36. And then the 1/2 is right here for my area. Now make sure that you are in degree mode because of course that will throw off your answer if you're not in degree mode. I'm checking my calculator, I'm in degree mode. So I'm going to go 10 cosine 36 times 100 sine 36 and then times 1/2. And I get that my area, and again we're rounding to the nearest tenth, is 237.76 or basically 0.8. And this is inches squared. And that is how you use the trigonometry to find the missing side lengths when you need to. So now we're going to let you try these 3 little guys. And then we're going to go to the area or to the part of our lesson that deals with composite figures. Now composite figure, basically the word composite obviously coming from compose, It means that you're taking different figures, different shapes, and you're putting them together, you're composing them, right? You're putting them together to create a new figure. So here we have, you can see there's a circle, there's part of a circle, there's a triangle, there's a rectangle, or parts of it that are making up this figure here. So the dimensions of a putting green at a miniature golf course are shown. How many square feet of carpet are needed to cover this green? So we basically need the area of this figure, but clearly we don't have any one formula that will do that for us. We're going to have to put several formulas together. We know the area of a triangle, we know the area of a rectangle, and we know the area of a circle. So we're going to take those different parts and we're going to add them all together. So first off, we have the area of a circle, pi r squared. But we don't have the entire circle, we only have half of it. So we're going to divide that by 2. We also have a triangle, and we have the area of a triangle is base times height divided by 2, right? 1/2 base times height. And of course, the area of the rectangle is just base times height. All right, so for the rectangle, we're going to go base is 4, height is 7. That one's the easiest one. 4 times 7 is 28. Let's show my work here. We're going to go, the base is 4, the height is 7. So we're going to get 28 feet squared, or square feet, for that guy. For the circle, we have the radius. The radius is 4 feet, so 4 squared and then divided by 2. So there we're going to get 4 squared is 16. 16 divided by 2 is 8, so we're going to have 8 pi square feet. And then we have, our last one is our triangle, base times height. So we're going to have, this is the only one that's going to be kind of weird because we don't have this segment here. So we can't just go base times height. If we use this as the base, we have to figure out what the height is here. So we're going to have to use some creativity there with that part. But what we can do for that one is use Pythagorean theorem, because it is a right triangle, because this is a rectangle, so this is the right triangle. So it means that we have a leg, hypotenuse, and we're missing the other leg. So we're going to go 4 squared plus x squared equals the hypotenuse, which is 5.7 squared. So 5.7 squared minus 4 squared, and we're going to square root that. So 5.7 squared minus 4 squared is 16.49, but the square root of that is approximately 4.061. All right, so now all I have to do is add them all up together. So I'm going to get 8 pi plus the answer that I just got, the 4.061, plus the 28. And my total area is going to equal 57. It doesn't tell us to round, but it says how many square feet, so I'm going to go ahead and round to the nearest whole number. We actually get 57.19, so that's 57 roughly square feet of carpet that you're going to need. You're going to need a little bit more than that because it's 57.2, so you're going to need 58, I guess, square feet. So there you go. Just want to make sure that I had the right dimensions here. 4, 4, 5. So, okay. Oh, I'm so sorry. I just realized I did something weird. I found X. I'm sure that Tammy probably already caught my mistake, but I found X but that doesn't mean that I know what the area is. I don't know why I just did that. I totally did not do the area. So let's nix that. This is not going to be our answer, but we still need this. So we need to do, this is our height right here. X is our height. So we wanted to go base times height and then divide by 2. So we want to go this value, 4.061 times 4 and then divided by 2. So you actually get 8.122 square feet for the area here. And now we're going to take that and add it with the 8 pi and add it to the 28. And you actually get 61.25. And again, if you want to have enough carpet, you're going to have to go to the next square foot. So 62 square feet of carpet are going to be needed. So sorry about that. I'm glad I caught that before I finished my video. Alright, so there we go. Now you're going to try this little guy. And then we're going to go a little bit backwards in our last example here. Same thing, it's a composite figure. But this time, we want to take away from the figure. Instead of adding the parts together, we want to use subtraction to find the area here. So this is obviously a rectangle. You can see that, well, the actual figure that we want is the shaded area. But if we kind of draw this in here, you can see that it's a rectangle. So we're going to take the area of a rectangle, which is base times height. So the area of the rectangle is just 5 times 6, which is 30 meters squared. But then we want to find the area of the triangle and then subtract that from the total area. Okay, and we have this is 4 and this is 4. So this is going to be an isosceles triangle. What we need right here is the height to find the area of the triangle. So remember, it's going to be 1/2. The base is 6 because it's going to be the same as this base here. And then we need the height. And so to find the height here, we're going to use the fact that this is an isosceles triangle. So that would mean that this is 3 and this is 3 because that would make it isosceles, right? So now we can use Pythagorean theorem, and you can get your last segment here, the height. So I'm going to go 3 squared plus the height squared, which is, this is my h value right here, right? Height squared equals hypotenuse squared. So h squared is equal to 4 squared is 16 minus 3 squared, which is 9. Square root both sides. So h equals the square root of 7. And so now I'm going to put that in over here. 1/2 6 times root 7. And we're going to get 1/2 times 6, which is obviously 3. And then times root 7. And we're going to get approximately 7.94. And so we're going to subtract that from the 30. So 30 minus my answer is basically approximately 22. It says round to the nearest tenth, and then there's a 22.06, so 22.1 meters squared. So, alrighty then. So again, this is just an example where you're subtracting a piece to get the actual area instead of adding the pieces together. Take the area of the whole, subtract the area of the white part, and that'll give you the area of the shaded part. So now we want you to try that in this example. And once you have completed this do-it-yourself question, you will have completed your notes for this lesson. And I will see you in class, and thanks for watching.